Andre got? What if he got flushed down the toilet?
He's disappeared.
Andre!
He's probably in the restroom.
Have you been flushed down the toilet?
It is normal.
Yeah.
He
Hey,
also went to the giant toilet.
we're recording.
I did not know that.
It's recording. We were just recording.
You just open the video and you hear the first 5 seconds. Giant toilet machine.
Okay. Everybody,
Yep.
look at it here.
Oh, he's not flushed down
Today
the
we-
toilet.
We have no quiz, but
Yay!
Did you hear that, Andre?
okay.
Dad, exit out of recording and do it again.
I
Redo
can't.
it.
I can't.
You can.
What?
No, just keep
No,
it that
it's
way.
fine,
Just go.
it's
It's
fine.
fine. It's
It's
fine.
gonna be saved either way, so.
Just crop it out.
All right. Let's refresh your memory. What's the PID control? What's the P?
Proportional.
Okay. What's this in I?
Integral.
Okay. What's this D?
Derivative.
Alright. All right.
You're all-
Wait. So just say let's try to have our formal.
Andre, please put your backpack in the cubby. Helena worked really hard to get it up there.
What?
Backpack in the.
Backpack in the cubby,
Let me
please.
know my stuff first.
Anyway,
No,
You need
not
to
everyone here is
micromanage
tall.
Just restart it. There's no going back.
No. Just keep on going. It takes too much.
And in the comments, just say start at like 8 minutes. Let's just start at 8 minutes.
all right. Let's have some. Let's settle down on terminology. Okay? Terminology is very important for engineer team. Without a good terminology, everybody talk this and that. What is this? What is that? Nobody understands what is this and that. Oh, this thing, that thing. Bring that thing here. I don't know what is that thing here. Or when you do the programming, you're yelling. Okay, just increase that value. What's that value? Right? Don't say what's that value. Use a terminology. For PID control, okay? Let's settle down the term. For the proportional, the stuff you try to adjust, we call it P gain. Because it's proportional. P gain. Questions?
Stop. Is PID used in gyroscopes and?
Oh, okay. Let's have a quick back a little bit. We got a new team member. Your name is
Aria.
Arya. Forgive me, my English is my third language.
I'll do it
Second is C++.
And I thought he said the second was Java or something.
No, second is C++.
Never mind.
Well, okay. PID control is a feedback control. Okay. Now let's go back a little bit. Okay. The basically idea is very simple. For all the control, we have open loop control. What is open loop control? Give me some example. You guys already know. What is open loop control?
Just keep.
Oh, you just run it.
Yeah. Just run it without any check. Say, me, go to buy me a sandwich. Okay.
What sandwich?
I never go back to check whether you give me a sandwich or not.
How much are you paying?
Yeah. Just give an example, right? For the robot, it say go to position XYZ. Just go there. Right? Then your second action is totally counts on your say position. Go to XYZ. Then you will go to XYZ, look for something or do next operation. Does the robot really go to XYZ? If it's not, all your operation after that is totally failed. Right? It's called open loop. What is closed loop control, guys?
Feedback control.
Yeah. Okay, what's the feedback control?
You get
It's
feedback.
like
and you act
making
on
sure
it.
Ming actually got you a sandwich.
Yeah.
Yeah. So if you ask the robot to go to XYZ position, you really go back to check.
No, that's not how it works. Actually.
Hey guys.
So where's that?
If it's really check it whether it get to XYZ or not. If not go to XYZ or has a little bit of gap, what should you do?
Change something.
Go back.
Adjust.
Yeah, adjust enforces go to XYZ. Like me, buy me a sandwich. 5 minutes later, where's my sandwich?
Stop playing games.
Yeah. Yeah, something like that, right? You have to do something to achieve your goal, right? So For all the feedback control, it's the magic. It is how do you implement a feedback control? How do you make this thing happen? That's the trick. That's a really tricky thing in a robot control, right? For example, you ask a robot to go to XYZ position, and when you check, it's really, say you have, maybe it's really good. Suppose you ask it to go to position 10, 10, 10, 10. Right? X equal to 10, Y equals 10, Z equals 10, right? But I'll go to different position. You go to 20, 20, 10. Then what should you do? What should you do?
minus 10, 0.
Yeah, it depends on how many motors do you have, right? How do you control the robot, right? Right? So actually the feedback is a little bit, you have to do a little bit mechanical calculation, matrix operation, but let's keep it simple. Today's class, we only talk about a one-dimensional change, right? We say if you move to a distance, then you have to really move to a distance, right? This is like how many people you implement the distance sensor. Only 2 groups finish distance sensor, right? Right. So what we I show up the So let me show you some video, okay? So can I share there? Which one? So basically, in last weeks we have basically requirement say, look at here. Hopefully you guys can see it, right? So
Why don't you show it on the big screen?
I forgot to upload to the Google Drive. Okay. So basically, what it is, it's moving forward. Oh.
Just swipe it up.
So basically, what we need to do it is.
Okay.
So basically, the robot will keep moving and stop in front of the wall, because on the tip of the robot there's an ultrasonic sensor. It knows how far away from the wall, right?
And then we can make it screen.
It can see through polycarbonate.
Sound,
Yeah,
right? Okay. So according to the programming requirement, you have to stop in front of the wall by, last time you said it's 50.
It's supposed to be 10 centimeters.
No, it's not 10. You change your parameters. You set it to be 30 or 50.
Yeah,
No,
something a lot bigger.
Yeah. Andrew said the distance to be 30 millimeters. 30 millimeters.
No, 30.
No, centimeters.
Oh, how many?
That's like
30 centimeter. Okay, it's 30 centimeter. But when you guys look at the distance, what does it stop?
Closer.
It overshoot, right? You overshoot, right?
PID. It's PID. It's,
Because we didn't do any PID.
Yeah.
Right? Because when you see it, it's already too late.
Yeah, it's the same thing with gyroscopes.
Right? So as a result, what we need to do from today, in next week's homework, today's homework, it is you need to write a PID control program to fix this part. You go there, when you see it's too close, you need to back up until you stop at the right distance. All right? All right? All right.
The idea is basically just the concept. The idea is important.
Yeah. The idea is very simple. The PID control, it is, you look at the arrow. So for example, the distance sensor, you are supposed to stop at 30 centimeter, but you stop at 10 centimeter. Then this is the gap difference, right? Then you should do something to feed it back. If it's negative, if you overshoot, you should use a negative power, right? So actually be smart enough, it is, you should not just go full power and you write an if loop to check the distance. The naive application, it is you keep checking the ultrasonic distance. If it's less than 30 centimeters, you stop. But when you see the 30 centimeter, you stop. You try to stop, but you overshoot, right? So if you have a better way, you do feedback control before you stop. When you are moving, when you are far away, you apply full power, right? High power. When you're getting closer, because the distance is smaller, you should reduce your power. Slow down. Don't overshoot. right? When you, for some reason you overshoot it, you should bring it back, right? So it depends on how well you tune these parameters. That if you're not tuning well, you oscillate like this: overshoot, go back, overshoot, go back, overshoot, go back. Never converge, right? So this is how we tune the p value. Basically, our p value it is PID control is basically like you use as a p gain. It's called p gain. P gain is a value. You times the arrow you see. Then that's your feedback power. Okay. I gain. It's an integral gain. It's based on history. You add up all your arrows in the last 5 seconds, 2 seconds, depending. Remember, there's a long-term memory and short-term memory issues, right? You add up all the arrows in last 5 seconds, and you times another parameter we call P, I gain, right? And you look at the trend. How's the arrow going to change? If the arrow changes really fast, then you should have some feedback to say we call D gain, derivative gain. Okay? D gain will prevent you overshoot. If you see this thing, your arrow decrease really fast, then you should not do proportional. Basically, this is negative, right? Right? Got it? So basically, the PID control idea is really simple. You just look at the 3 types of arrow. Current arrow, historical arrow, arrow trend, times a constant variable. Then you get your feedback power. Got it? In ultrasonic thing, in ultrasonic sensor, what you need to do, it is like this. First, you get a distance for, and here we use a encoder as an example, but you can swap this code. You can swap this code out by the ultrasonic distance, right? You get a distance, then you calculate the distance minus your target distance, then you get arrow, right? So everybody want to still remember why we need to do this?
I can barely see this.
Me either.
Why we need this code? Why we need this code? Why we need a convergent count? Why we need a threshold? Anybody still remember? Still? I'll show you the graph.
Okay.
First, why we need a threshold? Why we not say why we just say if distance minus moving distance equal to 0? Why not implement like that way? Because that's what you want, right?
Because you might go over it and then.
Yeah, it's never over perfectly precise, right? Right?
It's a curve.
Yeah, you basically need a band. For example, your mom say you have to get A this year. You have to, right? But what she's saying might be have the band. A plus, A minus, and A minus, A plus, or A. They're all A. That's a band. Got it? This is called band. Good enough is enough as long as it's A. A minus is A. Got it? Right? So you need a threshold such as to prevent you never reach your goal. Right? You have to. Does your model say you have to get a score of 99.888%? No way you can get a grade like that, right? Right? So this is why we need a threshold. For the distance, it's also affect how long you want to be okay. Because for annual game design, for example, in autonomous, you require a robot to pick up a cube like this. You require a robot to pick up a cube like this. Then what's the resolution? What's going to be the threshold? Say if you want to say the distance or moving distance, what's going to be the threshold?
The width of the cube.
Is the width of the cube? Say if you would design a clamp this, right?
Yeah.
Right? So, and in what threshold you think you are good enough to catch this cube?
How big is the clamp?
Yeah. How big your clamp can vibrate, right? Suppose your clamp is open. Suppose
Yeah.
suppose your clamp can only open this one, right? Suppose you can only open this way to catch this thing. So if you open like this, can you catch this? If you stop like this, can you catch it? No. If you do this, can you catch it? No. So that means you have a band, right? Right? If you stop like this, you can catch it, right? You can stop this, you can catch it, right? Then what's the tolerance? What's your threshold? What's the tolerance? Got it? So that means when you're supposed to stop exactly in the center, right? But you don't have to. Stop here is totally fine. Got it? So that's the threshold. So this threshold doesn't have any fixed value. It depends on your task. Got it? Okay. So right now you know why we need a threshold. First reason is it's never got exactly number. You never go to the exactly number. Right? Secondly, it's good enough is enough to save your time. Got it? Because the smaller the threshold, the longer it takes to control to fit there. Got it? All right. Okay. So can anybody understand why we need a convergent counts? What does this code do? If the data distance minus your target distance less than threshold, you increase the convergent count. Otherwise, you set the convergent count to 0. And in the end, you check if in convergent count bigger than 5. I made it up, right? It depends on task, right?
I
Right?
remember it being, you're changing the distance between the clamp and the object.
It's not changing. It's because why? It's why?
Maybe an accident, so you need to check it multiple times.
Yes. So it's say, for example, you write a program trying to catch a box, right? When the robot is still moving, your first check is right feet. Okay, so oh, I finished. But when you finish when you write after you check the distance, you say it's okay, but the robot is still moving. When you stop, it stop like this. You fail, right? So we need to check multiple times. One time is not good enough.
Well, in this case, if you move far enough, you won't be able to do
Right?
that anyway.
Right? So in that case, why we need to do this? What is this code doing?
Ensure it's not a mistake.
You need to this means you have to check it if it is really within the threshold for consecutive terms. You check it once, yes. 2, yes. 3, yes. 4th, no. Then you reset counter. Start over again. Basically, the idea. This is one simple way to say you have to multiple consecutive yes to have a confidence yes, right? This is like a sampling game. So for example, like today, how many times we say we can make all our robot keep working?
0.
Okay. There's some chance, right? Right? So in order to see your robot work, you have to check multiple times. Test it once, yes. You change something,
You said it 5 times.
but why does one robot doesn't work today?
So you're stupid.
No, because I think we did something wrong with the batteries or like the phones because the phones are connected.
Hardware problem.
Okay. Okay, that means we didn't catch something we are supposed to catch. In the next, this is why we need to sample multiple times. Got it? Okay. So if you, how many of you learn statistics or probabilities? You? How many of you know probabilities? How many of you? Raise your hand. As long as you know what is the probability.
What is
Combination theory.
Okay, everyone knows. Okay, so I just want to make sure you guys understand. In a box, within the box, if there's a 5 red ball and let's make it simple. In a box, there are 10 red balls, 5 green balls. If you blindly pick one, I'll ask my question here. What's the likelihood you get the green ball?
1/3.
1/3?
Yeah, you made a question before you asked it.
So what's the likelihood? Okay. What's the likelihood you take two balls at all at the same time,
Uh,
and all of them are red?
Wait,
that's
what were the
three-
numbers?
10 red balls,
1-6.
5 green
No,
balls.
no,
4-6, or no, yeah.
That is,
Four
it's a
nines.
round.
4 9s, which is,
It's
yeah,
a
4
round
nines.
1-6.
What?
No, no, wait.
Wait,
If
wait,
it's-
yeah,
All right, I'm just
Here,
gonna-
it's 4 9s. It's 4 9s.
Yes.
We have 10 red balls, 5 green balls.
Oh,
You blindly select 2 at the same time,
no, it's 4 9s.
2 at the same time.
No, it's two. Oh, wait,
4
at the same
9s.
time.
It's 4 9s.
Wait, what?
Oh, at the same time,
At the
sir.
same time.
So the
Okay.
point
Let's
is-
keep it simple. Keep it simple. Okay. Let's keep it simple. Right? In a box, 10 red balls, 5 green balls. You pick one ball out. Okay. You see the color. Okay. And you put it back. And take another random pick another ball out. You see the color. What's the chance you see 2 red balls?
4 9s.
How do you got this?
Because
Two
2
thirds
times
times
2
two
Times
thirds.
2/3 equals
Yeah.
4
Okay.
9.
Okay. Now, you have everyone understand why? Right? Everyone understand? Okay. Now, you have a box, 10 balls, the 10 green red balls, 5 green balls. Okay.
Wait.
Wait, what?
10.
Everything is the same. 10 red balls, 5 green balls.
Sorry.
Oh, okay.
Okay, everything is the same.
Yes.
Now, you use one hand and take out 2 balls at the same time. And take a look at the color. How what's the chance you see 2 red balls?
4 9s.
No.
At the same time.
Because you're
Yeah.
taking both out of the.
both
You
have it at the same time.
take
Yeah,
one
yeah.
out and then you have another one, so it
Oh,
goes
I
from,
got it.
it goes
It's
from 10 to 9.
it's 3/7 because it's 2/3 times 9/14. Because when you
What?
take one red ball out, then
Just do,
Just do
no,
all.
no, no,
Ten
no,
No, because he's
Everything
Five.
over
Okay,
something over
Well, that's what-
15 choose 2, right?
Okay.
It's just 2/3 times, and then now you have 9 balls, so 4 is 9.
9/14. I'm right.
Yeah.
9 over 14?
8 over.
Your man's
9
smarter
over
than
14
all of
times
us.
2/3.
Yeah.
Sure.
Well, yeah, it's 2/3, and then however many, so there's gonna be
9/14.
9 left and then 4 times.
Okay. This is today's homework. You guys go home.
It's a math.
You guys figure out either by yourself or
Don't we have 45 more minutes?
Wait, coach, what did you say? How many, what's the chance for 2 red balls?
Yeah, the last two.
Alright.
Sometimes I answer like 10, sometimes I answer like 7.
Sometimes he says it's 30 minutes and then it lasts for like 2 hours.
Alright, this is homework.
15
Don't do it here. I just want the homework, okay? I will update the homework. Okay? So- Right. Got it? Okay, anyway. So this is typical that why we ask this question.
9/21.
I said 3/7 something.
You're not supposed to do it right now, man. Shame on you.
Right.
But 9/21 is 3/7.
Yeah, I know.
But,
Yeah.
but.
I'm stupid.
I got it. Focus.
Wait, a second.
Focus now.
I just realized after you said that.
Hey guys, listen.
This isn't a very good impression, guys.
Hey guys, listen.
Expected one.
Do you guys know why we ask this question? Why we raise this math problem?
Because like, what do
Because you
do?
need to know logic. You need to know statistics for PID.
Yeah, because you have to like say the.
Because-
chances you're actually gonna get it
Because this is how you set up this number.
Oh.
right.
Because over here, right? Our logic it is we have to keep observing it. You want to see n consecutive, a number consecutive yes, to say it's yes.
Oh, there's only a certain probability that you will get that many yeses.
Yeah, right? So, for example, if you only, for example, I'll give you something, right? Suppose your robot wobbles somewhere somehow, right? One third of the time, let me say 1/3 of the time, if you're sitting in the your threshold band, 30% of the chance, because you keep wobbling, right? 30% of the time.
33.
Okay, just say 30. 30% of the time, because it's wobbling, right? For example, you want to pick up this thing, but your robot wobbles, right?
Yeah.
Now we say 30% of the time it's in a bed. Okay? 60% of the 70% of the time you wobble outside, right? And if we follow this logic, so we keep observing that, what's the chance you make a mistake?
How many times?
When I say how many, what's the chance you make a mistake? That means it is outside the band.
No. 70%, yeah.
Yep.
Oh,
Did you
there's a
just give us-
30%
But that's
chance.
for 5 times.
No.
then we need to pick
Oh, 5 times?
Hey, listen to my question. What's the chance you make a mistake when you only observe once?
70.
2/3.
70%.
One.
Wait, you just told us that.
Is it one- is it 1/3 or 30%? It's 30%, 70%.
Hey,
Translating 30% is 1/3.
Okay.
hey, look, because
So 2/3.
hey, 7. Follow my logic. Hey, follow my logic. It's because what I'm saying is because the rope keeps wobbling, right? That means this thing is not converged at all, right? It's not converged at all, right?
Yeah.
Right? When I say, what's the chance you make a mistake? It is, what's the chance this thing happen to be in the thing, right? Happen to be within the threshold, right?
That's
Oh.
30%.
That's percent, right? Okay, that's 30%. I already say this thing,
No, it was 30.
I didn't say 1/3 of the chance. I changed my number in the beginning. I say,
Okay.
right? I say this
So
thing
why
keep
is it only
wobbling.
70?
100
Because
minus
it's
30.
30 and 70.
That's 90.
What?
Oh my God.
30
I
times
just knocked over the water.
Okay.
Wait,
Guys.
That's someone's phone.
That's going into the phone.
Focus.
Yeah, so that was really dumb.
We are.
Hey, this is for most of the team, they find their trap. That's why the rope doesn't work correctly. Okay?
Right.
Focus.
It's functional.
Because our, hey, don't worry about it. Just focus on the cup. We'll check it out later. Fix it later.
If there's water damage, fix it later.
Okay. So our hypothesis is the rope keep moving because it doesn't converge, right? So we know that if you check once, 70% of the time we will make a mistake. Got a chance to make it. Oh no, 30% of the time we make a mistake.
I thought it was
I thought it was 70.
Just
You said
Somebody-
30%.
I
You said
originally thought it was
30%.
30% of the time we will make a mistake because even if in a 70% is outside the box, we make a correct call. So we say it's not converged.
Oh, okay. So
Right?
we're ready to stop.
So what you're saying is you make the code roll the dice to make the call 30% or 70% using data that you calculated.
Yeah, just assume that there's a robot, it's keep doing this, it doesn't converge at all. It's not converged. But if you only check once, because they have the 30% of look to converge, because it's within the band. I mean, 30% of the time you make mistake, because 30% inside the threshold, but it's not converged.
Wait, can I start to move by that time? So like.
Because the other 70% make a correct call, because it's outside the band.
Moving, right?
You're outside the band. You make a correct call, it's not converged, right?
It moves out.
That means if you only measure it once, that means there's a 30% chance you'll get it wrong.
Yeah, so then,
You'll be
oh,
measuring it,
yeah.
the 30%.
Yeah, that's wrong, right?
Yeah, because Andre, it's
Yeah.
not supposed to be, since it's wobbling.
Wouldn't it
It's
be
a 30%
outside
chance.
the
It's supposed to be outside.
No, so like, the correct call is that it's not in, but since the robot's wobbling, 70% of the time it's not in, but 30% of the time it wobbles in.
Because the call we're making is that it's not correct.
Yeah.
Right?
So 30%.
That means you're going to explain it.
So, I didn't understand.
Not in this section.
Oh, okay,
That's
alright,
the
alright.
measure.
Can I jump off some bill?
No. It's still not
Why
Yeah, that's what I
don't
thought.
we- why don't we-
It's
why don't we
outside.
just make a
The
program
correct call is that it's outside.
that takes measurements every time we do something like this, and then store the data in some sort of array, and then calculate the percentage for that. which
Yeah, this is
outside of-
exactly what we
Is
should
that
do,
forward?
Oh,
right? So this is why we need to check multiple times. We write your program, keep checking it, right? So now my question is, with all the number we have, right? What's the chance you make two consecutive measurements and you make a wrong call?
Both wrong.
Wait, what do you mean by wrong? Like at least one wrong call?
9%.
No, if the chance of failure is 30%, all right, can we just make it
Oh, the failure is
33.3 bar?
Yeah. You
Oh, so
go
we get it right.
Can we just make it 1/3?
So that's 49.
Yeah, let's just say 1/3.
We just say
Yeah,
1/3
so
because
1/9.
I don't wanna-
The chance of having failure 2 times is 1/9.
Why?
It's
Because
not
you're
1/3.
just saying it's 1/3 because like
No,
No,
no.
no, 30%. Just say 30%.
Okay, so
Okay,
that's,
okay,
and it's
so 3 tenths, so it would be 9 hundredths.
so it's 9%.
9%.
9%.
Is that right?
Yeah.
Yeah.
It's 9%.
Yeah, 9%, right? Okay. Now, hey guys, listen. Now, because this is you want robustness, right? So then my question is, how many times you need to observe that all within this band, right? You can guarantee that you have a 1/1,000,000th of the chance to get wrong.
1 million?
Yeah, 1/1,000,000 chance. Can anybody do this calculation?
3 to the something is 1 million. You take a log.
Yeah, do the calculation. How many times you need to
Log base 3 to million.
Just check it
give
once.
me a number?
Okay, well you just change the base form, right?
Log base 3?
Of a million.
It's like 3 to the. Oh wait.
Yo, nice, you got the marker wet too.
Wait, log base 3 of something
Oh,
equals
shit.
1,000,000.
No.
Wait, what?
That's wrong. That's so wrong.
What
That's
are
It's
so
you
wrong.
just how many
That's so
powers,
wrong.
how
That's so
many
wrong.
powers of 3 equals 1 million?
No, how many powers is 10?
No.
It's 3.
Even 10.
No.
Wait, okay, wait, we
No,
need to
it's
do
not-
something simple, so log
Say-
base,
I
This is why it's so much easier to
3
do
to the
1/3.
3 tenths to the x equals 1 over 1
Okay,
million.
just imagine
So then
it's
you take
1/3.
a log of 3x.
Okay, okay, forget about it. Let's do experiment, okay? 0.3, okay, times 0.3. That means if you check twice, they're all within the band. The mistake, you got 9% to get mistake, right? Okay, okay, keep going. Let's do this, okay?
We're just gonna roll.
2, yeah. 2 twice,
Can't you just take
2 times is 0.9, 3.
It's just 3 tenths x times. So it's equal to 1 over million. It's a log of 3 times both sides. That's it.
Oh wow, now it's only
It's not that
2.7% chance of getting
So
it wrong.
you're just dividing by 3 each time. So
Divided by-
divide by 3 until you get to the
No, it's not
last.
divided by 3. It's
Yes.
100%. So that's. it's
Not
3.
divide by 3, it's different.
Oh, no, it's not.
Yeah.
This calculate how you.
God darn modern technology.
So 0.3 to the power of x equals
Okay,
1
Twice.
over 1 million.
check it twice, it's 9%, right?
Okay.
3 times, okay,
2.7.
2.7, 3 times, 4 times,
Smaller.
Just
smaller.
keep on doing that until it
Five.
gets to the millionth decimal.
yeah, 5,
No, but like.
6, 7,
Oh my God.
8, 9,
You
10.
don't need to get this further.
Can't we just use a log?
Like we're done. Like we're done. Stop.
So what's the number?
12.
Bingo. Right?
Oh!
Right?
Wait, so
So,
your point is we should.
okay,
do that.
so, okay, listen to me. Hey, guys, listen to me.
Forget it,
What's the value?
now is not time to be discussing logarithms.
What's the conversion calculation?
Actually, it is because I do that problem with logs.
Hey, guys, listen. Now,
I think one thing.
okay, now, hey guys, now this number, how do you determine this number? This number is affect how much wobbling your robot is doing, okay? And what's the threshold you pick? And what's the chance it fell into the range? You can calculate the chance fell into the range, right? Then you calculate for 1 out of a million, you make a mistake in parking number here. Because in order to win the robotic scale, you always choose, never miss anything. 1 out of a million is usually is what the people wrong. Okay? 1 out of a million you get wrong. Because our pulling is so fast, we can pull like our robot for the encoder, it can pull 100 times per second. pulling 12 seconds, 12 times nothing, right? Right? So basically this number is a balance between how much confidence you want to put there and what's the frequency of your sensor, the budget you can do, right? You can increase this number a lot if your sensor pulling really slow. It's not good, right? Because it takes really long time to converge, right? Got it? Okay. So, hey guys. So this is why sometimes the code looks so simple. Okay, your code is done just like this, right? You just check how many times it converge and how many times it finish, right? I can just copy and cut. I can make a copy and paste and make it work. Ready? No. There's a couple of statistics right here. You cannot put arbitrary number here. If I put a 5, what's the chance I can make a mistake? If 30% get wrong.
240 multiplied by 6.
0.0024.
Yeah.
Okay.
6 right now.
So you have 2 out of 1,000 get wrong.
1,000? Oh, okay. So,
Oh, yeah.
I was like,
So 0.2%.
Yeah, 0 to 2% get wrong. Okay, this is not a very big number, but it could happen.
With $1 million, though. Right when you need it.
Yeah,
In competition, anything can happen.
yeah. Anything could happen, right?
That's why you can go.
Right. So in that case, basically what you need to calculate is your balance between. It doesn't mean this number is higher or better. The number it is you have to evaluate what's the cost of making a mistake. If the cost of making a mistake is a life and death, then you have to make this number really, really high. If the cost of number is just say slow down a little bit, then you can just right. Right? You can relax a little bit, right? Right? Got it?
But shouldn't everything be worth collecting? Or like,
For Robert, no, it's not. Because sometimes if you make the number too tight, you probably spend a whole 30 seconds in autonomous just to.
Same, yeah, you don't want to waste too much time. Yeah. Like if it takes under like
Elena, not the shine
if it's under 1% at that rate, just like it's good enough.
okay.
Did you say 30? Well,
Under
I never,
1%.
when I go home, I explain to you. Actually, that's it.
I understand.
Okay, good.
I'm just contemplating how stupid I am.
Hey.
It's not stupid.
Every people make mistake. You make one mistake doesn't mean you're stupid. Right? Every you make mistake. It's like the robot. Anything will happen. Don't play yourself. Here, hey guys, my coaching style. Tyler, can you not?
Sorry.
Every time you talk, you waste all these people's time. Right? My coaching style is I allow you to make mistakes. Right? Every people make mistakes because you guys are learning. Right? You guys are learning, right? But on my side, if you make mistake once, I think you're learning. You make it exactly same mistake twice. I will say, okay, you have to work harder, okay, because you make same mistake. If you make the same mistake third time, I will say you need to seriously think: are you either in focus or are you really understand the knowledge point? Because my coaching style it is you can make first a couple mistake. If you keep making the same mistake, I will assume that you don't understand the knowledge point. Got it? I will go back to you, make sure you understand the point. Got it? I never will blame you're stupid. You make the same mistake because you're a student. If you don't understand, of course you make the same mistake. Okay? Question?
Should I get a paper towel?
Sure. Okay. Got it? Okay. Don't feel any shame if you make mistake. Alright? So because when you keep making same mistake, in my view, it's just you don't understand. Got it? It's those people stupid. Right?
7 plus 3.
-3 times 2 is 5.
Okay. So everybody understands the session now, right? Right? Okay.
Ow.
That's what I do all the time. -3 times 2 is 5.
Oh. Wait, what?
Because my brain is that intelligent.
I mean, the absolute value of 3.
Hey guys, we only have.
Close.
Okay, what's next?
Okay. So you guys totally understand why we need this now, right? Okay. So it's going to be in the quiz. Okay. In the quiz, I will make up some numbers and let you guys question the number. Okay. So basically, I will ask you what threshold is supposed to be set and what is final convergence was supposed to be. Okay. You have to.
say what threshold should be set.
What?
You didn't go over what threshold.
Okay. What threshold to be set is depends on.
How big
I'm going to give you one example, right?
What will work?
Right?
Yeah, I know.
For example, your claw is this big. Right? You want to catch this thing. Then when you do your calculation, then what's the threshold is going to be set? The threshold is going to be this gap here. Because that's the maximum error you can make.
Yeah.
My memory just, I forgot.
Right?
So are you gonna, in the quiz, are you gonna give us like a real?
I will give you one case. Okay? Similar, but not exactly. But you know, once you know the idea, what's the threshold, how to pick the threshold. You need to how to calculate.
So we'll be asked to set the threshold.
Yeah.
And the
In that case.
quiz is like this.
You can retake it if you failed it.
Oh,
You can retake it. We always get like 4 out of 10. It's kind of weird.
Because we're bad.
Don't feel proud of it because I know every. Hey, don't feel proud of it. I know every score you take. First trial is how many? Second trial, I know everything. I don't feel. I'm not looking at the final number. Right?
I thought you let someone else take the first try.
Yeah, that's what I did with Caitlin, and I got it 100% in like 40 seconds. He looked at all the answers off of my sheet.
Bruh.
Wait. Is this?
Don't you make an anti-cheat? You can like protect.
Alright.
If
Anyway.
it's under like.
Okay.
It's definitely cheating.
Okay. Let's settle down 110.
You just leave fake answers on there.
Hey guys, listen. Let's go back to terminology. P gain, I gain, and D gain. You guys all understand what they are, right? P gain, I gain, and D gain. Right? So there's also the nickname. I gain, sometimes people say reset. D gain, somebody call pre-act. Pre-act is predict for future, right? Reset it is you look at the history, you do something, reset, right? But I will go this way. Let's settle that. P gain, I gain, and D gain. Basically, they are the 3 constant values put before the proportional, current arrow, a cumulative arrow, and an arrow derivative. Got it?
F mean function?
What? F means a floating number. Right? It's a float number, right?
Oh, okay. This isn't. Okay, never mind.
Okay, let's move on next one. Okay. Then we need to have a move to the next topic because in the homework you guys need to learn how to tweak this PID control. Because most of your PID control programming, it is you tweak this value either by hand or by a program, such that your robot move as fast as it can and precisely. Okay. So let's have another terminology. We know what is PID, right? We also need to say P value. What is PV?
Wait, I think we went over this already last class.
Yeah, but still.
Let's recall. Okay, mean. I tell you what is SP?
What?
You say you take this guy. What is SP?
No, I said you went over this last class.
Okay, well, did you remember anything? Hey, how many people know understand what is SP? What is SP? What is VP?
Some set point and yeah, that's what I said.
PV is a process value.
I can't remember
It's not even on there.
Okay. PV is a process value, basically what you read from a sensor. Got it? SP means a set point, your desired value, where you want to go to. When you guys discuss how to tweak it, you guys have to use the term. Otherwise, you guys totally lost. Because PID already a little bit complex, right? Right? Arrow, what is arrow? The difference between the PV and SP. Okay. Got it? And what is OP?
Overpowered.
Means output.
Offensive power rating.
Basically, whatever the
OPR.
hey guys, listen. Basically, it depends on what feedback control you want to put into. Some feedback control is the motor power. Right now, most of the cases is motor power, right? Some cases it's not a motor power. Some cases it is the current, the voltage. There could be another factor because we can actually DC chain PID control. You guys know that? We can DC chain. Do you guys know what is DC chain? That means that the output of a PID control is the input of another PID control. This is chain it together. Got it? All right. This is whatever the output. And we all have to say overshoot it is the PV value move further. You guys know what is overshoot now, right?
Yes.
Okay. Now the goal of turning PID loop is to make it stable. Couple of purposes. Make it stable, responsive, and to minimize overshooting. Got it? Got it? Okay. Responsive, that means you have to get your control, reach your target as fast as you can. You cannot just make a couple of days to finish. Okay. Stable, it is you don't have that thing out of whack. Say in that extreme case, my PID control go out of whack. It's return 1 million power in. Right? And minimize overshooting, it is overshooting. Sometimes overshooting do really harm to things because overshooting usually means huge risk. For a car, if you want to, what is overshooting?
Crash.
Yeah, if you want to brake, say in front of a, for example, if you want to drive a car, brake in front of the cliff, what does overshoot means?
You fall off the cliff.
Well, if the cliff is like a centimeter high.
Yeah.
Well, that's
It's not a cliff.
Okay.
Well,
Okay, another thing.
yes, it's not a cliff.
Do you know that?
You're running over
Do you know that why we have a really stable like voltage? We have really good power in the city. Why? Because they have a very good feedback control. How do they deliver power? If the power deliver or distributing algorithm is not stable, all of a sudden you distribute all the power to one district. You can set the district on fire.
Unless
I don't think that'll happen.
Unless you
because
had-
there's like
Yeah.
This is how
there's like transformers and like different stuff in the grid.
they've
Like,
voltage
stop that kind of
control
stuff,
like
yeah.
resistors
Yeah.
and all sorts of stuff to make sure like the voltage.
Yeah.
It's called the surge protector.
Yeah, that.
I mean, the voltage has nowhere to go. It'll just heat up,
Okay,
and then
okay.
they have heat boxes.
Okay, good. So let's move on. Okay. So hey guys, now we're going to teach you how to tweak the p value. What's the p value? P gain. What is p gain? P gain. This is one example. Okay. So do you guys know what is overshoot? Overshoot is which curve? This curve, right?
Yeah.
Right.
That's what you're.
This-
That's what you are.
Okay, this x-axis, it is the time. X-axis is time. The y-axis, it is arrow. Right? No. The y-axis, it is the value. The blue line, it is where you want to go. The blue line, okay, give it to me. I don't want anything distracted. Anything move, I hate it in the class.
You get all of that.
Wow.
Okay. Whoa, it's not school.
Okay.
Welcome to the.
Welcome to America.
Okay. So,
Apparently people.
hey guys, listen, focus.
People make jokes of school shootings
Wait.
in other countries I've seen before.
So what's the
Jake's left the talent show.
Yeah.
Oh, shoot.
what's bad about this curve? Hey guys, Elena.
You told us that it was fine.
It's
told us it was fine.
wavy, so it's
No.
gonna go
It's
like.
too slow.
What? Yeah. What is this purple curve?
It's a gradual.
That's way. It takes a
It
really,
takes too
really
long.
long
To
time.
adjust.
Takes too long to put critically down.
So what we want to do it is the green curve. Green curve only overshoot a little bit, then come back. And-
last lesson you told us the red one's okay. It's not so good.
Yeah, but
Look-
you see, the red one aligns closer before the blue one, which is, I think it's.
This
purple one is
this one align a little earlier.
Wait,
The
Yeah,
green
actually,
one.
The green one is the best.
Yeah, green one is the
Yeah,
best.
that's
The
what
red
it
one
said.
is only if you
Isn't
don't
blue,
want to
isn't blue
overshoot.
line just like God? Just.
The blue line is just the red one.
Yeah, I know, that was a joke.
Blue one is where you want to go.
Yeah, I know.
Ideally, you should say. Ideally, you should from.
What happens when you have a portal?
Yes, exactly. That's what I want to say. Blue one is this exactly.
Portal.
Blue one is this exactly. It happened instant. Okay. Not such a thing. Okay.
Like, if you did a portal, you still have to drive into it, so you have to be teleported.
Okay, maybe it's the random comment you made.
No. Hey, me.
You're right.
Me, actually, you make a mistake. The portal curve is not like this. The portal curve, it happened before this. It happened here.
No, the portal, you still have to take
No, you have
time.
to go towards
You
the
still
portal.
have to take time to go through the portal.
That's a time machine then, not a portal.
There's no line.
Portal is a time
It's
machine.
not possible
You
to
have
get the
instant
blue line.
transmission, you know what that
The
is?
blue line, it's not
You
possible.
can't be in two places at one time.
Yeah, you go
I don't know.
faster than anything.
Yeah, no, but actually, if you go
No,
faster,
you
Whenever
can't
you get
get
that
that
blue
blue
line,
line,
you go to the
Oh my God, that smoke is undefined.
I hate move. You can't get that blue line because if you go
Yeah,
through
no.
time and when you look back, you can keep on, you can appear in the same time.
Most of the time.
So you
Alright.
put this.
You have two life bars close in the same different places at the same time. It's the same part.
Okay, discussion's over. Okay, come back to here. Come back to here. So finally, you guys understand what is good, what's bad, right?
Yep.
Okay,
Just get some back and stop.
yeah, super bad. Super bad is this purple line. Is it purple? I'm colorblind. Super bad is a purple line,
Yeah,
right?
because that never is even on the line, and the points that is on the line are like from one tiny point, and then for the rest of it, it's like inconsistent.
Anyway, so basically you need to tweak your K value. If you make it too big, you will overshoot. The P gain, if you make the P gain too high, you will overshoot. You make a P gain too low, you never reach it. You have to adjust it somewhere. You will overshoot a little bit and come back. That's the fact. How can you get the P gain? Got it?
Yay!
Okay, let's look at the I gain. Me. How do we adjust the P gain?
What?
What is P game?
How do we adjust the P gain?
you proportionally reduce it by like saying x equals x minus 1. Or, yeah. Or x
You're
plus
not
y.
doing
Okay, let's go and come back to here. Okay, so in order to get a P gain, okay, so you just set a value, right? You observe how the robot reacts, right? Just set one value, right? If the robot just slowly reach the stuff you want to say, for example, you want to move the robot to a constant distance. If you set a P value too low, robot will probably never move or move here really slowly. All right, that means your P value too slow. If you set the value really high, the robot will slowly but overshoot, all back. Then you never converge, right? So that means, and after you observe these two, congratulations. That means you already make a progress because you know that's the upper bound,
That's what happened last year. The robot had an epileptic.
right? Right? Hey guys, listen. How many of you know the binary search?
Binary.
Binary search.
Binary, sir.
Binary search, it is when you want to search for a value, right? Search your value.
Divide by half and-
You always divide it by half and try it again.
It's Zeno's
Right?
paradox.
No.
But like the
Not
averages and
paradox,
everything, what
binary search. The way to find the value. It's like, so if I ask you to pick, so if I pick a number between 1 and 100, and I ask you to keep on guessing and then tell me if it's lower or higher, you're going to use binary search.
Then if it's greater than
The
75.
purple one, then the purple is just a
It's
really
pretty
terrible
easy to
version
have
of it.
every time.
Okay, I teach you how to do it, right? It's like this.
Just play the game. Choose
You-
a number between 1 and 100.
Let's take a P,
Call your number, brother.
let's take a PID control as an example, right? So you know the lower bound. Hey guys, listen. You set your P, you set your P gain to 0.5, right? You notice this thing low, really slow, right? Then now you set the P value to 1.6. You notice it oscillates, right? Overshoot, right? Then the next try, I will choose the middle point of this and this. Right? To have a
Would
try.
that be 1.05?
Close enough.
Would that be 1.05?
I'm not saying I'm going to pick this. I just need to say.
But that's not the middle. 0.5, 1.6.
I didn't say this is the middle point. So the next thing I will try is 0.25. You guys listen. Listen.
Stop touching the wood.
You guys not.
You don't touch it during class, and if you're not gonna use it, don't unwind it.
Sorry.
And moved it.
What's he gonna do?
Okay. Sometimes I feel like I'm talking to kindergarten people.
You might as well.
Okay. So this is an example. You get a value is too low. Okay. You see that the overshoot the value, right? Then the next value you will try is the middle point of these two values, right? When you try it, you will make a judgment again. If you think that's a little bit overshot, then that's a new boundary, the top value, right? If you observe this still little sluggish, you will say that's a low value. You choose another question.
How does the green value work?
Oh, this here they just drew what?
How does the green one work?
What do you mean? How do you know? This doesn't has to be.
The blue one that's waving up and down.
Yeah.
What?
The blue one's fine.
Blue one is bad. It's got overshoot.
Yeah, I know, but I'm just
Oh,
saying that.
blue.
It's just a really bad version.
Yeah.
What are you talking about?
Technically,
I was just asking, how does the
No,
green one
the
work?
first one and the second one are just random.
What?
No, the first
So
one.
What are you
The
talking
first
about?
one's
They're not random. It could
First
be
one
called
is-
a.
or
The
random.
first one is
They're
using
just better by
They're all
it.
using
And
binary
one of the
search.
two-
Yeah.
This one overshoots by
Find-
more.
Well,
Well,
it's not binary
one,
search,
right?
it's binary search
If
equals
it's too
two.
slow,
Yeah, and then you go
then you go
higher.
higher,
Yeah,
so
yeah,
then that's too fast, then you meet in the middle,
Okay.
and you're like, oh, this
That's
is.
not binary.
The point is, they're all
Yeah,
more
it's not.
sophisticated versions
No,
of
it's
the other.
not. It's not even
Okay.
close.
Okay.
I is a more sophisticated version of
Divide by
B.
two.
Exactly.
I'm like, what?
He's the one dividing by two.
Yeah.
So you get-
All right, that's very good. I would say let's stop to this lecture and start the discussion right now. To say how do we tweak the P value based on the binary search?
X plus plus.
What?
You guys make a flow chart. Okay, guys.
Let's just do heaps. That's what I do.
Do not later, okay? Because, so this is what I propose, right? So you just randomly set a value. Don't know about value, right? Just randomly set a value.
Okay.
I
Pick a number
you
between
upload a value to your robot. You upload a value to a robot. I just see whether a robot is overshoot or undershoot.
Yeah, and that's your.
Do
Do you know what time it's working in?
In 10 minutes.
Oh,
Okay, just-
It is.
That is a lot. It's 9 o'clock.
Okay.
8:30.
Suppose an 8:30.
No, it's 8:22.
So this is what I propose. Then after that, you guys discuss, right? So you get a random value, load to the robot, then let the robot do the work, and you observe is an overshoot or undershoot. Overshoot is doing this, right? Undershoot slowly go up, right? If it is overshoot, that means the value is set. This is the maximum value. You cannot more than that, right? Right? Yes.
Raymond, always join the table. You're getting a shade
Now,
Is that necessary during? like-
now you do another random. Make the p-value to be much lower, right? Because you know the maximum, right? You make it much lower. Until you see it's got sluggish undershoot, right? Then you get your bottom limit, right? Then you can do binary search in between, right? If the new middle point is overshoot, then what you do? Then you're going to
Find the
do
middle point of that.
yeah. Then what? How do you do the which part?
Divide by two.
How do you
What do
calculate
I do?
sluggishness?
You
Or,
the sec,
yeah.
the middle point and then the thing.
Lower
Like
bottom
the red
part.
line.
Yeah,
You take the middle
midpoint.
point of the current value and
Yeah,
the
so
bottom
AG
part.
is midpoint.
What?
A question, so if, is the red one
Like,
using
if it
the
looks
derivative?
sluggish, If it looks.
The red one's
it's
using
bad,
the
it's
derivative,
like-
right?
No. Here we still talk about the p-value,
Yeah.
proportional.
But the red one, is it
No,
using?
no,
the
you
So
said the
it's
derivative?
all,
value
it's
is
all
for
AP,
API.
it's all
Oh,
P-value.
it's
It's
all-
all
I'm talking about
P-value.
everything.
Oh, I see.
They're all p-values.
Oh.
It's not a string or string value. This is all p-values. Let's just choose different p.
Oh, okay.
What's the behavior when you choose different p value?
No, you do the binary search.
Jonathan.
Okay.
What's so funny about PJ?
Okay.
Oh, thank you.
No, you find the